Deep within a Martian crater where the red dust swirls and the silence is profound, a rover the size of a car diligently scours the landscape, its wheels leaving faint tracks in the ancient soil. It is on a mission, a quest driven by human curiosity and the desire to understand our place in the cosmos. A mission to uncover the secrets of a planet that has captivated humanity for centuries, a planet that once might have harbored life. Amongst the red dust and jagged rocks, it spots something unusual, something that stands out against the familiar Martian terrain. A black rock, out of place in this alien landscape, catches the rover's sensors. This rock is unlike any other found on Mars. It holds the potential to rewrite the history of our solar system, to challenge our understanding of planetary formation and evolution. Could this be a sign, a whisper from a time when Mars was not the desolate world we know today? Could it be evidence of ancient life or a different geological process? This is not a scene from a science fiction movie. This is the reality of space exploration in the 21st century, where every discovery brings us closer to answering age-old questions. This is the reality of space exploration in the 21st century, where rovers and orbiters work tirelessly to gather data and send it back to Earth. Scientists at Curtin University in Australia, led by Dr. Valerie Payré, have been at the forefront of this research. They made an astonishing discovery while analyzing data from NASA's Mars Reconnaissance Orbiter, a spacecraft that has been orbiting Mars since 2006. They found this enigmatic black rock nestled within the vast Jezero Crater, a site believed to have once been an ancient lakebed, teeming with water and possibly life. This ancient lakebed, now dry and barren, holds many secrets of Mars' past, and this black rock might be the key to unlocking them. This seemingly insignificant rock, dark against the rusty Martian soil, stands out not just in color, but in its potential to reveal new information. It holds within its structure tantalizing clues to Mars's distant past, clues that could tell us about the planet's history and its potential to support life. What secrets does it hold? What stories does it have to tell about the ancient Martian environment? The answer, my friends, may just rewrite our understanding of life in the universe, challenging our perceptions and expanding our horizons. To understand the significance of this discovery, we must first journey back to the cradle of life on our own planet, Earth. Imagine, if you will, the primordial Earth, a world teeming with volcanic activity, its surface still cooling from its fiery birth. The air was thick with gases, and the ground was a molten canvas of creation and destruction. In this chaotic landscape, hydrothermal vents, fissures in the Earth's crust spewing scalding water, played a pivotal role in the emergence of life. These vents were like underwater geysers, releasing not just heat but also a rich mix of minerals. These hydrothermal vents, often found in volcanically active regions or near tectonic plate boundaries, release geothermally heated water rich in dissolved minerals. This mineral-rich water created a unique environment, a cauldron of chemical reactions. This chemical cocktail, far from being inhospitable, provided the necessary ingredients and energy for the first single-celled organisms to emerge. These microorganisms thrived in conditions that would be lethal to most life forms today. Life, it seemed, had found a foothold in the most unexpected of places. These early life forms adapted to the extreme heat and pressure, turning what seemed like a hostile environment into a cradle of life. The discovery of thriving ecosystems around hydrothermal vents in the depths of our own oceans, hidden from sunlight and thriving on chemosynthesis, revolutionized our understanding of life's tenacity. These ecosystems are home to a variety of organisms, from giant tube worms to shrimp, all relying on the chemical energy provided by the vents. Could similar environments on ancient Mars have provided the same spark for life to begin? The presence of ancient water sources and signs of past volcanic activity on Mars suggest that the red planet might have had its own hydrothermal vents, potentially creating the conditions necessary for life to emerge. The search for life on Mars continues, driven by the hope that we might find evidence of life's resilience beyond Earth. The black rock, our enigmatic messenger from Mars' past, holds secrets that have traveled across millions of miles and eons of time. Contained within it are microscopic time capsules known as zircon grains, which are like tiny windows into the ancient Martian environment. These tiny mineral grains are incredibly durable, capable of withstanding the relentless march of time for billions of years, enduring the harshest conditions imaginable. They are, in essence, miniature record keepers of geological history, preserving the story of Mars's ancient past within their crystal structures. The team at Curtin University, using cutting-edge nanoscale geochemistry techniques, meticulously analyzed these zircon grains, unlocking their hidden secrets. What they found sent ripples of excitement through the scientific community, as it hinted at a Mars that was once very different from the barren landscape we see today. The zircon's chemical signature bore striking similarities to those found in ancient hydrothermal systems on Earth, suggesting a shared history of geological processes. The presence of specific isotopes within these grains pointed to an environment rich in water, heat, and minerals, the very ingredients that could have supported life in Mars's distant past, sparking new questions about the planet's potential for habitability. These zircon grains whispered tales of a warmer, wetter Mars, a stark contrast to the arid and frigid world we know today, painting a picture of a planet that might have once been teeming with the conditions necessary for life. The similarities between the Martian zircon's chemical signature and those found in Earth's hydrothermal systems are too compelling to ignore. Could it be that Mars, once upon a time, possessed an environment much like the one that birthed life on our own planet? Imagine, if you will, a younger Mars, its surface dotted with volcanoes, its atmosphere thicker and warmer. Water flowed freely, carving channels and pooling in craters, forming lakes and perhaps even oceans. And in this ancient Martian landscape, hydrothermal springs, fueled by the planet's internal heat, bubbled to the surface, creating pockets of warmth and chemical abundance. The possibility, however remote, sends shivers down the spine. Could life have emerged in these Martian hot springs, only to be extinguished as the planet's climate changed, its atmosphere thinned, and its surface water disappeared? Section 5. Perseverance, Unveiling Martian Secrets. The discovery of the black rock and its zircon treasures comes at a time when our understanding of Mars is undergoing a renaissance. NASA's Perseverance rover, which landed in Jezero Crater in February 2021, has been diligently exploring an ancient river delta, collecting rock and soil samples for future return to Earth. Perseverance's mission is not just about rocks and minerals. It is about searching for signs of past life, biosignatures that could provide definitive proof that we are not alone in the universe. The rover's instruments are capable of detecting organic molecules, the building blocks of life as we know it, and its sophisticated cameras can capture images of microscopic fossils if they exist. Section 6. The Ancient Martian Oasis. The evidence from the black rock's zircon grains, combined with Perseverance's ongoing exploration of Jezero Crater, paints a picture of a Mars that was once far more hospitable than the cold, dry desert we see today. Jezero Crater, believed to have been a lake billions of years ago, holds particular promise for finding signs of past life. Imagine, if you will, the shores of this ancient Martian lake, its waters fed by rivers and streams, its edges teeming with microbial life. Could the remnants of these ancient Martian microbes be preserved in the sedimentary rocks of Jezero Crater, waiting to be discovered by Perseverance's instruments? Section 7. A Universe of Possibilities. The search for life beyond Earth is one of the most profound endeavors in human history. It is a quest driven by our innate curiosity, our desire to understand our place in the cosmos. The discovery of even simple, single-celled organisms on Mars would be a paradigm shift, fundamentally altering our understanding of life in the universe. If life could arise independently on two planets within our own solar system, it would suggest that life is not a fluke, but rather an inevitable consequence of the laws of physics and chemistry, given the right conditions. The universe, with its billions upon billions of stars and even more planets, would suddenly seem teeming with possibilities. Section 8. The search continues. The search for life on Mars is far from over. Perseverance continues its exploration of Jezero Crater, its every finding scrutinized by scientists around the world. The samples it collects will eventually be returned to Earth, where they will be analyzed in unprecedented detail using the most advanced instruments available. The black rock and its zircon treasures have given us a tantalizing glimpse into Mars's watery past, a time when the red planet may have been more blue. The question remains, did life ever arise in those ancient Martian hot springs? The answer, my friends, is still out there, waiting to be discovered. Section 9. Are we alone? We live in an age of extraordinary discovery, With each passing year, we peer deeper into the cosmos, unraveling its mysteries and pushing the boundaries of human knowledge. The search for life beyond Earth is a testament to our insatiable curiosity, our desire to know whether we are alone in this vast and awe-inspiring universe. The evidence from Mars, while not yet conclusive, is compelling. The red planet, once thought to be a dead world, may yet hold the key to unlocking one of the greatest mysteries of all time, the origin of life itself. And if we find that life did indeed arise independently on Mars, it would forever change our perspective on our place in the cosmos. For we would know with absolute certainty that we